It's 7:03 in the morning. Oh my god. And I'm gonna be working on a project, so first thing I gotta do is no. Um, this and this I need open. And coffee. I got coffee. Sorry if you hear that. Must suck. Alright, let me quick open up. Shut up. There we go. Alright, so we have the simulation of the shits. We have the controller, and I should really name this to worker. We have the worker, and then we have the controller code and the worker code. You can see if we run it, look at the oscilloscope here. Oh, we're running in slow motion. Okay, so what's happening here is the controller is pulling all the addresses in its address space, which is technically 0 to 255, but in the actual application, it's going to be 16, so I can probably change that. And it goes through each address, and it pulls each address on the bus for its whatever instruction is stored by. This is the wrong one. Whatever instruction is OXAF. I just got a notification. Hold on. Okay. So yeah, so that's what's being sent, and then it's responding, and all of the worker is responding with is whatever instruction it receives. So the worker will always send 1 byte back, at least for level 1 communication, and yeah, it'll just send the 1 byte that it got as an instruction back, because currently the instructions mean nothing. Normally I could add in like an if statement, if inst equals like OXAO, and then do something and return a specific byte for that instruction. But that is not where we're at. So currently, if we look in here, you can see it starts with the oh yeah, hold on. This obviously is 1. This is the binary representation of the number 1. So that's the address that the worker is currently listening to. So we can see that the controller sends out a communication packet for address 0, and then it sends its instruction byte here, and this is the start bit, and it waits 2 seconds to receive a response before it moves on, and it returns a 00, if there is no device found there. Like if there's no response, essentially it's a timeout. Then it moves on to address number 1. It sends out its start bit, and it's 1, and then all the zeros for the rest of the address, then the instruction, and then it receives the response, which is, you can see the similarity here between this and this. You can see this area is slightly larger than this one. That's because it includes a start bit. So yeah, so you can see it sends out a message and gets a response. It doesn't wait 2 seconds because it doesn't need to. It immediately sends out for number 3. Waits 2 seconds. So you can see how this tends to go. It waits 2 seconds before trying number 4. So that's how timeout works. I explained that on my story a bit yesterday. And so the next thing to do would be to open up my Google Docs, and I have one for this. So I have all of these are like all of the attachments that can go on to this bus and can be communicated with. So I need to define level 1 communication. So I want a bulleted list for this. All devices. Okay, so I want an instruction 00. That's a status, or that's like a identifier basically. So it's identifier. So what this does is the LSB to bit 4 is a number is a 4-bit integer unsigned. Integer representing the this should be representing the level of communication of the device. So I haven't explained this yet, but basically the idea of the level of communication is that I can update all of this stuff. So like if I have a level 1 main board, every device must be able to function at level 1 to ensure compatibility with that board. If I have a level 2 board, it still has to support level 1 communication, but it also has level 2. So if a device is level 2 communication, then it must incorporate all the functions of level 2 and every level below it, which in this case is just 1. So like a level 3 card would have to support 3, 2, and 1. Like it's just building off of more is the idea. Bit 5 to MSB is a 4 bits unsigned integer representing the type, the device type. Oh. Yeah. So basically, what I should do is I should implement this right now so I can just go through the list. So the idea is if I say this address, this instruction is what I send over, it should return a byte where the least significant bit to bit 4 is a 4-bit unsigned integer representing the level of communication. In this case, it'll be 1. And bit 5 to the most significant bit is a 4-bit unsigned integer representing the device type, and these are the device types here, so I should probably assign these all a number. And this has to be in hex, but only 1. OX1, OX2. I'm going to copy the OX because it makes my life so much easier. Here, I can copy the whole thing of this, actually. Let's do that. And that. Okay. 3, 4, 5, 6, 7, 8, 9, A. Alright. So these are all the things it can return as a device type. And then for now, each of the devices is going to have um, LSB be um, LSB is going to be. I don't remember what I was saying. I just like zoned out. I'm sorry. All right. So let's go implement that. I'm going to make. No, I don't want PyCharm. I always do that. Yeah, shut up. All right. Let's go in here. Close this. We're going to name this because we're going to make it a specific type now because we kind of have to. So let's call this lighting. Lighting worker. All right. So let me get rid of this thing because I don't need it. And this. Okay. So I can also get rid of this all. And one of these because it's, wait. Yeah, it was exactly the same, but whatever. All right. So let's go implement that in the worker. So if we go to the state callback, so we're going to do an if statement. If the instruction is equal to OXOO, which is this, then we now know that we are being called for our identifier. And this will be a constant for a device. So it should just be the 1 byte. So it returns a byte where the least significant to 4 bit isn't. Okay, so that should, the second part of it should be a 1. First bit should be so I should have a 5 hex 5-1. So if I go into here and I go to a hex converter and I do, what was it, 5-1? Yeah, OX 5-1. You can see our least significant bit on the right here is to bit 4 is a number representing the level of communication. That's what I did in that order, right? Yeah, which is 1. You can see that's 0001. That's just a 1. Then this one, 5, is just the identifier for lighting. And that number doesn't mean much. It's the, what is that? 1, 2, 4, 5. Oh yeah, that makes sense. That's decimal 5. So here we are. That was fairly easy enough to implement. I got to build this. So now you can see if I listen on, I'm going to listen on 0 because it just makes my life easier. If I go back to here and I ask for that, and I start the simulation and I open this, there's my ping, and it looks like I got a response. Oh, it just sent all zeros, but you get the idea. So it sends all zeros, and then it sends the binary message. So that's one down. That's all I really have for all devices supporting something. So I should really, no, that's not what I meant to do. I should really move on to now, I guess, like the lighting devices. Devices that control lights. Pattern based should have at least 20 patterns. Should have, not at least, just 20 patterns. All right. So OXOO is used. That cannot be used as an instruction anymore because the level 1 communication is all of these. So we have 255 possible communications for any type of device. We cannot exceed 255 instructions. So, 16. No, I can't do that. I'm going to need a different instruction for each one. Yeah, I'm just going to do 16, because, right, that's 4 bits of freedom, gets you 16. 1, 2, 4, 8, that adds up to 15, so yeah. Yikes. So I'm going to have an entire chunk of instruction space filled with this, which is extremely inefficient. That's something I could build on with level 2, where I send an instruction and a data packet. But I don't feel like doing that, so ha. So we're going to do OX01. Lights off. Return value should be OX01. I'm just going to say that. Because that's just telling it to do something, as long as, because remember, returning OX00 is like our fault. We don't really want to be returning a fault, so OX01 is like a success. I'm gonna quick mark that down in here actually. Returning OX00 is a fault on the part of the device, and the controller will ignore. OX01 is the byte to send after successfully completing the task. Should a response not be needed? Turns all lights controlled by device off. Should really just be marking what this does instead of just what it does, or what it returns. Used to identify the type of device and its communication level. Return value should return OX01. All right, let's go implement it. So we go to the worker, and first thing I'm going to do is I'm going to change up this circuit. No. Let's move the oscilloscope out of the way. So you can see we still have all this I/O. So this is from the lighting. Let's just add a light. Or actually, let's add 4 lights. And I'll explain later why I'm doing that. LED bar. Can I change how many's on this? Yeah. 8. I like orange. Cool. Okay, so I'm going to need to rotate this clockwise. I'm going to hook this up. Oh wait, I wanted 4, duh. And I'm going to need a ground. I'm going to need a 100 ohm resistor. I know this is not how electronics works, but here we go. Resistor. 100 on. Let me just move this down. Connect this. Connect this. Connect this. Connect this. Boom. Okay. And I'm going to connect this to port. I'm going to put this on port B, I think. Oh, where's B0? There it is. Oh, perfect. Okay. I'm just going to move that a little. I'm going to move these 3 to bruh. To bruh. Oh, really? Is that how you want to do that? Can I just do this? Yes, I can. Okay, so port B. I just want to match that up. I don't really think I want it here, do I? Because then I have to shift it. It's fine. It's just easier. Okay, so you'll see in a minute why I've just done that. So, let's go implement it in Microchip Studio. So we know this is a lighting controller. If the instruction is equal to OXOO, oh no, not OXOO, OXO1, that's the light. I think I defined it as lights off. I don't even remember. Yeah. We're going to add one more LED. But I want this one to be separate, so I'm just going to do this. And then... Okay. Whatever. Okay, so yeah. So that's that. So this LED is also doing the same thing, yada, yada, yada. Okay. So, what we're going to do is... This is just something for us to see. This is not part of the lighting. This is something to ensure that the instruction is working properly. This is our lighting output. Isn't that fun? So, let's do stuff with it. So I have to set the data direction register port B to be all outputs. I don't need to remove a DDRB. OXFF. All right. So it's on B4, which is actually the 5th one. So I'm just going to do a register thing. So I'm just going to do port B equals, or we're going to do an and equals. I'm going to and it with OB 11111. Okay. So that would normally make it so that it just lets it go. But this should be 1, 2, 3, 4, 5 in from the least significant bit. 1, 2, 3, 4, 5, 0. Shut it off. So basically that'll make it so if this light is on, it won't touch any other thing on the port, but it will shut this one off. I think. Let's go turn it on, and oh, something we can do. Turn it on and test it out. I have 5 minutes left of this recording. I'm only doing half an hour at a time. So that's that. That should do that. That. Let's go send the instruction. I want to turn it on first. Port B. OX. I was wrong. Because it has to be from that side. Okay. So let's turn this on. Nothing happened. Why did nothing happen? Is that the wrong thing? 1, 2, 3, 4, 5? It's B4, right? Wait. Is it this one? Oh, I didn't build it, that's why. And because I didn't do that, what the hell? I don't know what you're talking about. Oh, works now. Okay, sure. And I have to go in here, and I have to set this to 0x01, because that's the instruction. Then we build it, then we go in, and we start the simulation. It still is not on. I'm calling that a video.